Hello, hi everyone. Welcome to the Student the Brand. Hello students. Welcome to the Student the Brand. So this is our Shiva sir. So now we are going to discuss about work, energy and power. Today's topic is work, energy, and power. Okay. So work, energy and power. So what is work? Daily we do so many things. Daily we do so many things. That is carrying the books and bringing groceries, so bringing vegetables and filling the water bottle and placing in the fridge, so or drinking water. Okay, and we are doing so many things. So what is work? When we apply force on the object moves from one point to another, or simply the object displace from one place to another place. Okay, that is called work. So here, like you can see, carrying the luggage, right? So trolley is there. Easily we can drag the trolley, right? So easily we can drag the trolley. So in markets you can observe. So we are pushing the trolley. Okay. So we are moving the objects by applying force. So displacing the table, the moving the bag from one place to another place. Another. So these are examples for work done. Here there are three types of work done. So based on the force and displacement acts on it. So here I am taking this the object. I am applying force on it. This the force, and this one is the displacement. The force and displacement, the angle between force and displacement is theta. The angle between force and displacement is theta. Understood? The angle between force and displacement is theta. So here in scalars and vectors, I explained scalars and vectors. Okay, scalars and vectors topic I explained. In that if you check, so resolving the component place, very important. Resolving the component. So actually this concept is very important. It's resolving the component like along x-axis, y-axis, z-axis. So now we will take two coordinates, because along x-axis, y-axis will consider. Along x-axis and y-axis will consider. Okay. So here you can observe. So this is the x-axis and y-axis. The force is acting, right? So this is the force component. This is the force. This is the force. F. So along x-axis, the angle is making with x-axis theta. So this is x, y. Okay. So this is the x component, this is the y component, and this is the x. Now cos theta formula. From this cos theta. So adjacent side by hypotenuse. Adjacent side is x, hypotenuse is f. So x equal to f cos theta. And coming to the sin theta, that is y by f. Now y equal to f sin theta. Understood now, dot? Cos theta equal to x by f. sin theta equal to y by f. So here cos theta, x equal to f cos theta. F cos theta is the responsible force component which is moving the object along x-axis. The object is moving along x-axis direction only, right? Object is moving along x-axis direction. So F cos theta is the force component along x-axis. So F cos theta is the force component acting along the x-axis direction, because when we apply force on the object moves along the x direction. And y component also there. What is that? F sin theta. Y component is there, that is F sin theta. F sin theta is acting upward direction. But object is not moving upward direction, no? Yes sir, no, object is not moving in upward direction. So object is moving along x direction. Object is moving along x direction. That's why the force component which is acting along x direction is F cos theta. F cos theta is the responsible for the movement of the object along x direction. That is a force component. When we apply force on the object is moving. So if you resolve the component, if you resolve the force into two components along x-axis and y-axis, along x-axis we are getting F cos theta, along y-axis we are getting F sin theta. So F cos theta is the responsible for the movement of the object along x-axis. Along x-axis. Understood? Yes. So when you lift the object, that is true. When you lift the object, that time y component plays, y component of force. That too, y component of force plays major role. Okay na? So y component of force is responsible for the movement of the object along y direction. When we are lifting the object along y axis. But here when we apply force on the object is moving along x direction. So you are pushing the table. So you are not pushing like this. You are pushing like with certain angle. Understood or not? So we are applying force with certain angle along x-axis. Along x-axis. Understood or not? So F cos theta is the horizontal component which is responsible for the movement of the object. That's why, so now you can observe, that's why, so double equal to force into displacement. So F bar dot S bar double equal to, work is a scalar quantity. The dot product of F bar, the dot product of force and displacement. F bar dot S bar. Those are two vectors. Okay. So now you can see F bar dot S bar. That is F cos theta into S. That is double equal to Fs cos theta. Double equal to Fs cos theta. I hope it is very clear. Understood or not? Double equal to Fs cos theta. That is a work done formula. Work done. Work done. Understood or not? So now you can see one more. So here work done is positive, work done is negative, and work done is 0. So when we can say work done is positive, work done is negative, work done is 0. Okay. So this object, so force is acting on it. So force and displacement are acting in the same direction. Force and displacement are acting in the same direction. Then we can say work done is positive. So force and displacement both are acting in the same direction. That time theta equal to 0. Okay, so these are very important. Cos 0 is 1, cos 90 is 0, cos 180 is -1. These three values are very important. We will use here. So you can observe in the trigonometric table sin theta, cos theta, tan theta, sin 0, 0, sin 31 by 2, sin 45 1 by root 2, sin 60 root 3 by 2, sin 91. So reverse of sin only cos. Cos 0 1, cos 30 root 3 by 2, cos 45 1 by root 2, cos 60 1 by 2, cos 90 0. So likewise here double equal to fs cos theta. Cos 0 is here. Fs cos 0 is 1. Then we can take Fs. Double equal to Fs. Maximum work done. Work done is maximum. Maximum work done. Maximum. Okay. Coming to the next one. Force and displacement are acting perpendicular to each other. Okay. So if force and displacement are acting perpendicular, then theta equal to, so here force is acting like this, displacement will be acting, then the angle between force and displacement is 90. Okay. So best example, when the porter is carrying the load, acceleration due to gravity acting downward direction. When the person is carrying the load, acceleration due to gravity acting downward direction. So displacement along horizontal direction. The angle between the two is 90 degrees. Understood? I hope it is very clear. Now, so double equal to Fs cos theta. Fs cos theta, theta equal to 90 degrees. Then double equal to Fs cos 90. Then double equal to 0. Work done is 0. Cos 90 is 0. Work done is 0. Work done is 0. Understood or not? Now next one is work done. Double equal to Fs cos theta. Fs cos theta. Here, so force and displacement are acting opposite to each other. So the angle is 180 degrees. Force and displacement are acting opposite to each other. Angle is 180 degrees. That time double equal to Fs cos 180 degrees. That is Fs equal to minus Fs. Work done is here 0 work done. 0 work done. 0 work done, maximum work done. And here is the minimum work done. Minimum. Here is the minimum work done. Minimum. Is it clear? Work done is maximum. Work done is 0. Work done is minimum. So I hope it is very clear. Understood or not? So with respect to acceleration due to gravity. With respect to acceleration due to gravity. Okay. So next one energy. So we'll discuss about energy. energy. So now we will discuss about energy. Energy is nothing but capacity to do work or ability to do work. Ability to do work or capacity to do work is called energy. Energy. Okay? Energy. So energies are, one is kinetic energy. Kinetic energy. The second one is potential energy. Potential energy. One is kinetic energy. Second one is potential energy. What is kinetic energy? Energy possessed by the body by virtue of its motion. If the body is in motion, then the body having kinetic energy. So if you lift a body from ground to certain height, if you lift a body, yes, work energy theorem. Say simple only. So I'll explain work energy theorem with the help of, so when I am explaining kinetic energy only, I'll explain work energy theorem. Okay. S of m square is formula, kinetic energy formula. Right. Now, so energy possessed by the body by virtue of its motion is called kinetic energy. Right? Yes. So now we will discuss about kinetic energy. Kinetic energy. Kinetic energy. Right? So I'll give one situation. So work done on the object is equal to change in kinetic energy. That's enough. Work energy theorem is nothing but when we apply force on the object comes under motion. So work done equal to change in kinetic energy. Change in kinetic energy. Okay. So here the object is here. So m is mass of the body, initial velocity u, and after traveling certain distance, yes. So same mass is not changing because same body only. So but velocity is final velocity v, and if change in velocity is there, automatically acceleration is there. If change in velocity is there, automatically acceleration. So we know v square minus c square equal to 2as from equation of motion. So v square minus c square equal to 2as. And from Newton's second law, F equal to ma. F equal to ma and equation of motion. Now we know work done equal to force into displacement. Force into displacement. Whatever the work we did on the body, that will comes to kinetic energy, that is F equal to ma. And here from this equation we can write S equal to v square minus c square by 2a. V square minus c square by 2a. Understood or not? Substitute the values. V square minus u square by 2a. So a get cancelled. Kinetic energy equal to, okay, so m into v square minus u square by 2. So k equal to, so here of mv square minus of mu square. So that is work only, right? Work equal to half mv square minus half mu square. So numericals, yeah, of course. So we'll do numericals. Okay. So as of now, we are going to the concept. After completion of concept, so we'll discuss numericals also. Okay. So now that only work equal to, so change in kinetic energy. That is work energy theorem only. Okay. So now if the body is starting from rest, this entire task becomes 0. Then kinetic energy equal to half m square. K equal to half m v square. So understood? This is a kinetic energy formula. Kinetic energy formula of m v square. Is it clear? Of m v square. So one check it. One check. So kinetic energy is nothing but energy possessed by the body by virtue of its motion is called energy possessed by the body by virtue of its motion is called kinetic energy. So W equal to force into displacement. Whatever the work is done on the body, that will become in the form of kinetic energy. K equal to m into v square minus c square by 2a. So that is equal to s. Okay. So that is the formula of kinetic energy. Coming to the potential energy. Coming to the potential energy. Potential energy is nothing but potential energy. Potential energy is nothing but energy possessed by the body by virtue of its position. Energy possessed by the body by virtue of its position. So we are lifting the object. We are lifting an object from ground to a certain height. This object mass is m, so it is lifted until height h. Okay. So this is A equal to G and S equal to H. Okay. So what are the acceleration? That will be the acceleration due to gravity. So what are the work we did on the object? Whatever the work is done, oh thank you, Aman Mishra. So whatever the work is done on the body, so that is equal to double equal to force into displacement. Force into displacement. Okay, so whatever the work is done, that will become in the form of potential energy. Potential energy. So F equal to ma and S. So S equal to H and A equal to G. Potential energy equal to mgh. So this is the potential energy formula. So thank you so much, Aman Mishra. Thank you. Okay. Now we can see here, we can see potential energy formula, potential energy, potential energy. Thank you, Kohinoor Yadav. Thank you, man. Okay. So please do like, share, and subscribe, and share to everyone. Okay. So I need your support. Without your support, I can't reach. So I'm doing. So you can observe the work what I'm doing. So try to share to everyone. So I need help from you all. So in order to share and subscribe and send to everyone as soon as possible. So share to everyone, all your students. Okay. So make the work to reach everyone. So thank you so much for your support. I need your support. So do the support and share to everyone. Share as much as possible. Share as soon as possible, because whatever I'm doing work, that work must reach to everyone. Okay. So I need this work to reach everyone. So to maximum number of students. So to get, students should get benefited by observing the content and utilizing the content. Okay. So I need that. So do like, share, and subscribe. So thank you so much. Okay. So now come to the point. Power, power, power equal to rate of doing work. Rate of doing work. P equal to W by T. P equal to W by T. And the SI unit of work is joule. SI unit of work is joule. Okay. So SI unit of power is what? SI unit of power is what? 1 horsepower equal to 746 watt. Okay. So these are the points. These are the points. So thank you so much for joining and attending and listening my class. Okay. So this is your Siva sir. Sorry. So thank you so much. This is your Siva sir from Student the Brand. So do like, share, and subscribe to Student the Brand. We'll see in the next class with a different topic. Thank you.